Welcome to the probability lecture. And this is absolutely one of my favorite topics because I teach statistics, and so this is a big concept. Before we go jumping into probability, we need to talk about counting, right? And how we count things in order to identify, then turn those into fractions, and then hence probabilities, percentages, etc. So we're going to start with the fundamental counting principle. All right, if you choose an item from a group, right, and the second item from the group, then the total of the choices is the multiplication of those two. And that's a very, very simple concept, right? So a restaurant offers 10 appetizers and 15 main courses. In how many ways can you order a 2-course meal? So that would be 10 possible appetizers, 15 possible main courses, and hence 150 options. So simply just multiplying the possibilities. A pizza can be ordered with 2 choices of size, medium or large, 3 choices of crust, and 5 choices of toppings. How many different one-topping pizzas can be ordered? All right, so 2 sizes, 3 crusts, 5 toppings gives us 30 options. So again, very, very simple concepts here. If you are taking a multiple choice test that has 6 questions, each of the questions has 4 answers, A, B, C, D, with 1 correct answer per question. If you were to guess on each of the questions, in how many ways can you answer the questions? So this comes down to, we could do 4 times 4 times 4 times 4 times 4 times 4, 6 total times. And then I want you to understand that we can simplify that by just doing 4 to the 6th, which would be 4,096 ways. All right, so we're going to get into various questions. And basically, I want to start this off with a diagram. All right, so counting diagram. Because basically, we started with the simplest way, and that's always the best thing to do. When you ask your question, you start if repeats are possible. You ask the question, repeats. All right. If the answer is yes, all right, then we use the power rule. Jeez Louise. And basically what we just discussed. We're basically multiplying. If the answer is no, then we Then we need to ask another question. Does order matter? So if there are no repeats, this is when we change. All right. And for the power rule / multiplying, just as a note, order is irrelevant. So then this becomes another question. If the answer is yes, we're going. If the answer is yes, we are going to do permutations. And we're going to talk about this in a minute. If the answer is no, then we are going to do combinations. And so this is basically the entire concept of identifying what's happening with counting principles. All right, and we're going to keep coming back to this chart. Okay, so before we get into permutations and combinations, we need to talk about what a factorial is. All right, In your calculator, if you have a TI-84 or better, all right, math, PRB, and then you select the factorial button, which is just the exclamation point. And basically what a factorial is, it is the reduction, all right, of each value minus one and then being multiplied together. So a lot of times we can just write this out. Let's look at an example here. In how many ways can you arrange 5 books along a shelf, assuming that the order of the book makes a difference? So the fast thing to say here is that this is 5 factorial. And what that means, I can also do what we call the blank method. All right. You have 5 spots. All right. In the first spot, all right, I would put one of the 5 books. Then in the next spot, now I have 4 books, and then 3 books, and 2 books, and 1 book. And you multiply these possibilities together. And that's actually what a factorial does. So a lot of times we don't even have to write out the factorial. I just do the blank method and then just multiply 5 times 4 times 3 times 2 times 1. And that gets us 120 ways. All right, so permutation. And this is where, again, the calculator is kind of helpful. All right. But again, if you don't have a calculator, or you can, Google like some calculator online to do this, but a lot of times you can just do the formula here. All right. N factorial all over n minus r factorial. All right. The calculator, doing this in the calculator is pretty nice because it is pretty fast, but a lot of times I can also do these with the blank method. And so here's the big thing. All right, I have permutation and distinct objects. All right, without repetition, order does matter. Look back at our chart. Okay, no repeats. All right, so we're down no repeats, yes order, and that's a permutation. Okay, so how many 3-letter code words are possible using the first 8 letters of the alphabet if no letters are repeated? All right, and then if letters can be repeated. So if no letters are repeated, so again, both of these actually can be done with the blank method, and then what you put in there will change. So I have 3-letter code words, which is why there's 3 blanks. Okay, so no letter can be repeated, which means the first option, I have 8 letters, and then I have 7 letters, and then I have 6 letters. And then multiply that out. So 336 words. If letters can be repeated, that means I have 8 letters, and I can repeat, which means I have 8 letters, and then, oh look, 8 letters, which is the equivalent of what we're calling the power rule, 8 cubed. 512 words. And so notice on that first step, all right, back to our chart. No repeats, order does matter. That was actually permutation again. In the second case, repeats were allowed, which means we went to the power rule. All right, so serial numbers for a product are to be made using 2 letters followed by 3 numbers. If the letters are to be taken from the first 8 letters of the alphabet with no repeats, and the numbers are to be taken from 10 digits, 0 to 9, with no repeats, how many serial numbers are possible? Again, no repeats, no repeats, no repeats. This is a permutation. So again, I like to do this with the blank method. So our first 2 are letters from the first 8, which means that's 8 times 7. And then followed by 3 numbers, all right, from 10 digits, which means 10 times 9 times 8. And again, I can do this basically flat out every time just like this, which gives us 40,320 possibilities. Now, as a note, you can write this out with permutations as well. All right. In the calculator, that would be 8 NPR 2 times 10 NPR 3. And that would get you the same value. And you should verify that for yourself if you have a calculator that can do this. A corporation has 7 members on its board of directors, and how many different ways can it elect a president, vice president, secretary, treasurer? Okay, so this one actually changed slightly. It didn't straight out say that there were no repeats, but all right, we are going to assume, all right, that the president and the vice president cannot be the same person, which means no repeats. When you have distinct groups, this is kind of the thing that I can't have that same person be 2 different positions. So again, I like the blank method, which means I had 7 members, and then 6 members, and 5 members, and then 4 members, and multiply away gets us 840 ways we can do this. All right, so permutations of duplicate items. This does kind of use the factorial equation. And so you want to be able to at least do factorials in your calculator, because you have the total number of options in the numerator, all right, that we are pulling from. And then you reduce it by the factorial of the repeats. And it's just kind of this is a fun way to identify when you have repeat categories. So in how many distinct ways can the letters of the word Mississippi be arranged? And so the idea here is that we count all the letters here, and there are 11. So there are 11 letters. But we have repeat letters, right? We have 4 S's, which means that's 4 factorial. We have 4 I's. We have 2 P's and 1 M. And the denominator, notice, sums the numerator. 11 on top, all right? 11, 4 plus 4 plus 2 plus 1, 11 on bottom. So unfortunately, this is the part where if I was to write this out, this is 11 times 10 times 9 times 8 times 7 times 6 times 1. So that's what that becomes on the top. On the bottom, this is 4 times 3 times 2 times 1. And then that again, 4 times 3 times 2 times 1. And then 2 times 1, and then 1. So, I mean, you could put it in your calculator like that, all right? It just becomes, it's way easier to put it in your calculator as factorials. But when you multiply that out, you would get 34,650 ways. Similarly, in how many distinct ways can the letters of the word osmosis be arranged? So there are 7 total letters there, all right? And then there are 2 O's, 3 S's, 1 I, 1 M, and that is the total 7. And so again, 7 times 6 times 5 times 4 times 3 times 2 times 1. And then in the bottom, 2 times 1, 3 times 2 times 1, and then 1, 1. And then multiply that out, and we should get 420 ways. Okay, so combination. So here's our other case, and actually combinations are more common than permutations, because a combination is no repetition and no order. You're just selecting items from a group. And this has a lot of applications, as we're going to see. Again, same thing in the calculator. This is NCR versus NPR, all right? And this is the last category in that diagram we made, right? So no repeats, no order, that's a combination. All right, so in poker, a person is dealt 5 cards from a standard 52 card deck. How many different 5-card hands are possible? Poker hands are possible. And so that's the whole thing, right? When you get a card, it doesn't matter if you get the ace first or if you get the ace last. All right. So order doesn't matter. And also, there is no repetition because when you pull a card out of the deck, you don't put it back into the deck to then keep getting cards, right? You have a finite number of cards in the deck. So this one, and this is where we really we want to use the calculator because it's 52. All right, choose. So we have multiple ways to write this. 52 choosing 5. You can also write it as 52 NCR 5. And the formula on this one is a little bit annoying if you were to do it by hand because you have 52 factorial in the top. All right. 5 factorial, and then that's subtracted, which makes 47 factorial. Now, the benefit here is that you can still kind of do this by hand. It's just kind of a pain. But here's how you do it. So 52 times 51 times 50 times 49 times 48 times 47 times 46, etc. And in the bottom, I would have 5 times 4 times 3 times 2 times 1. And then I had 47. I would have 47 times 46 times 45, etc. Now, the nice part here is that notice the numerator, 47, 46, etc. All those cancel with all these. So really in the numerator, you only have 52 times 51 times 50 times 49 times 48 divided by 5 times 4 times 3 times 2 times 1. So you can still do this, all right, without the nice function in your calculator. But definitely, I mean, while you're doing the home funds, things like that, you should Google it and see if you can figure out how to do it in your particular calculator. Like I said, I used to show it for TI, like TI calculators 84 and above. But the problem is then someone has a TI 30 and you have to figure out how to do it in that one. And someone has a Casio. So Google your calculator, know how to use it or how to do it on your cell phone. But anyway, we would multiply those out and we get 2,598,960 poker hands. And that is the probability if you've ever looked at how to play poker and the probability of getting, 4 of a kind or something, that is the total number of hands, all right? That's why there's a lot of amazing variability with just 52 cards. Distinct cards, that is the important part. They are distinct, right? Okay. So, from a committee of 10 people, in how many ways can we choose a chairperson, vice chair, secretary? And this one even specifies, assuming that one person cannot hold more than one position. So before we kind of have that assumption, this one specifies that cannot be the case. So this is always back to that diagram. What case are we in? Okay, so no repeats. All right. And then does order matter? Yes, order matters because they're distinct positions that people are holding, which means we are doing a permutation. Which means, again, I like to do the blank method with permutation. It works the best. All right. Combination is really the only one that doesn't work with the blank method. So with that, that means I have 10 spots, then 9 spots, then 8 spots, which again, I could also write as 10 NPR 3. Both those come out to the same thing, which gives us 720 ways. In how many ways can we choose a subcommittee of 3 people? Now, notice the difference here. All right, no order. So no order in this case, which means this is a combination. Since that is a combination, then, I mean, again, I can do the formula, but I'm just going to write this out as NCR3, and you can plug it into the formula or your calculator, which gives us 120 ways. And in how many ways can we choose president, vice president, secretary, if more than one position can be held? And now we are in the top case, right? What we're calling the power rule, all right? The top case of our diagram. Because as soon as you say repeats, that means you're basically doing the blank method and just doing that, those possibilities raised to a power. And so that means I have 10, 10 times 10 times 10, aka 10 cubed, which is 1,000 ways. All right. A company has 7 senior and 5 junior officers. An ad hoc legislative committee is to be formed. In how many ways can a 4-officer committee be formed so that it is composed of? Right. Then we have options, which are basically going to break us into various groups. Any 4 officers. So in all this case, all right. So no repeats. So we see, all right, 7 senior, 5 junior, 4-officer committee. All right, and they didn't specify the officers, so we are just identifying officers are everybody that is at this company. All right, so there are clearly no repeats. We're pulling those people, and all right, there is no order. Doesn't matter who we're selecting. So the first one is any 4 officers. So I had 7 senior, 5 junior. That means I'm pulling from all 12, and this is then a combination. So that's 12 NCR 4 people, which then gives us 495 ways. All right. If I'm looking for 4 senior officers only, that means I have 7 senior officers, NCR 4 from that. And then that means of the 5 junior officers, NCR 0. Now, be aware that this number right here, that's 1. There's only one way to pull 0 people. And so basically, I put that there just so you could see that, all right, I'm still accounting for all 12 people, all right, but that number just becomes 1. So the only calculation I have to do is the 7 NCR 4, which then gives us 35 ways. All right, I want 3 senior officers and 1 junior officer. So now this is very similar to what I just did. Of the 7 senior officers, I'm pulling 3. Of the 5 junior officers, I'm pulling 1. And so notice that these two numbers, 7 plus 5 makes 12, 3 plus 1 makes 4, right? So I'm still accounting for both, all right, both senior and junior officer groups. And again, this, when the numbers are this small, you can plug this into the formula and then do this by hand. I'll just leave those calculations to you. And then lastly, I'm looking for 2 senior, 2 junior, which is pretty much the same thing. 7 NCR 2, 5 NCR 2, which then gives us 210 ways. All right. All right. We will leave it there. Combinations, permutations, and the power rule. Have yourself a wonderful day.